All right, strap yourselves in because today we're diving deep, really deep into the Large Hadron Collider.
The LHC.
Exactly. The LHC, um, the biggest machine on the planet.
It is indeed.
27 kilometers, a ring
Yeah,
buried underground near Geneva.
that's right.
I mean, try to picture that, like across a whole city.
Yeah, it's hard to grasp the scale.
But why? Why are we smashing particles at near the speed of light? What's the big deal?
Well, it's all about unlocking the universe's secrets, really. By studying the tiniest pieces of matter, we can unlock huge mysteries.
You're talking about how everything works,
Mhm.
like from the smallest atom to the largest galaxy. We got a lot to unpack today. What the LHC actually I asked, what it's trying to achieve, how this mind-blowing machine works,
Right.
and most importantly, why should we care? What does it mean for science, for tech, even for how we see our place in the universe? And I've got a fantastic expert here with me to help us understand it all.
I'm glad to be here. I'm always excited to talk about the amazing work being done at the LHC.
Before we get into it, though, we can't talk LHC without talking about CERN,
Yeah.
the European Organization for Nuclear Research.
Absolutely.
That's the home of the LHC.
It is.
It's this global hub for particle physics. And it's incredible to think about scientists from over 100 countries working there together.
Yeah, it's a great example of international collaboration. It truly shows what humanity can do when we work together.
And speaking of collaboration, did you know that CERN is also the birthplace of, well, the World Wide Web?
It is.
Wait, really? So the internet came from particle physics research?
Yeah, it did. Back in 1989, a scientist named Tim Berners-Lee, he created the World Wide Web at CERN.
At CERN.
Just as a way to share information, to make it easier for researchers to share what they were finding.
So that little spinoff kind of changed the world.
Yeah, you could say that.
But let's get back to the LHC itself. Paint me a picture. What does this thing look like down there?
Well, imagine a tunnel, a huge tunnel, 27 kilometers in circumference and buried sometimes 175 meters underground. It spans the border between Switzerland and France.
Like it goes between two countries.
It does. And
Oh.
inside this tunnel, you have these incredibly powerful magnets
Magnets, okay.
that are superconducting, and they're actually colder than outer space.
Okay, colder than outer space. I mean, I thought my
Yeah.
freezer was cold.
They're extremely cold.
What are these magnets even for?
Well, they bend beams of protons which are racing around this LHC at almost the speed of light.
Wow.
Imagine a racetrack, a cosmic racetrack with protons as these tiny spaceships being guided by these super powerful magnets.
Okay, so giant underground ring, super cold magnets, protons zipping around at ludicrous speed. What are they trying to do with these protons?
Well, they're smashing them together.
They're smashing them together.
Yeah, head on.
On purpose.
On purpose.
Why?
Because when they do that, they create an environment like the conditions just fractions of a second after the Big Bang.
Okay, so they're recreating the Big Bang, essentially.
Well, it's not exactly the same as the Big Bang,
Right.
but it lets us study, the fundamental building blocks of matter and the forces that control them.
Right, but I mean, it's still, I mean, so you've got these proton collisions and new particles are appearing. How do scientists actually see this? It's tiny, it's super fast.
Yeah.
It's all happening so quickly.
Well, that's where these amazing detectors at the LHC come in. There are 4 main experiments: ATL, CMS, ALICE, and LHCb.
Right.
And each one is like a giant specialized camera designed to capture different aspects of these collisions.
I see.
They track the paths of these particles, measure their energy, and identify what type of particle it is.
So it's like trying to understand a Swiss watch by smashing two of them together at high speed and then just analyzing the pieces.
That's a good analogy.
Yeah.
By studying those pieces, we can piece together the underlying workings of the universe.
But you mentioned the protons need to be going almost the speed of light.
Mhm.
How do they get them going that fast?
Right. Well, it's a multi-step process.
Okay.
The protons actually start their journey in a bottle of hydrogen gas.
Okay.
They're stripped of their electrons and then accelerated through a chain of smaller accelerators, gradually increasing their energy before they're finally injected into the LHC.
So it's like a series of warm-up laps before the main event.
That's a good way to put it.
So we've got these protons zooming around and colliding. What happens next? What are scientists hoping to find in these collisions?
Well, one of the biggest goals was to find the Higgs boson.
Right, the Higgs boson. Now, that was discovered at the LHC back in 2012, wasn't it?
It was, yeah.
Because they built this gigantic machine to find a single particle.
Well, it wasn't just any particle. The Higgs boson is responsible for giving other particles mass. You see, without it, the universe as we know it wouldn't exist.
Oh. So no Higgs boson, no us. It's like the missing piece of the puzzle, the thing that confirms the theory.
You could say that. It was a major victory for particle physics.
Right.
But it's not the end of the story.
Okay, so what else are they looking for? What other mysteries are out there?
Well, there's dark matter, for example.
Dark matter.
This invisible stuff.
Yeah.
It makes up about 85% of the matter in the universe.
85%. And we have no idea what it is.
We don't know what it's made of, no.
Okay, invisible matter that we can't see or touch, but it makes up most of the universe.
Yeah.
That's pretty crazy.
It is.
And the LHC could help us find out what this dark matter is made of.
That's the hope, yeah.
Yeah.
If dark matter particles are produced in these collisions,
Right.
they might interact with the detectors, leaving behind some kind of signs that we can analyze.
Okay, so unmasking dark matter, that would
Yeah.
change everything.
It really would. It would be a huge paradigm shift. And then there's supersymmetry, or SUEY for short.
Right. Susie Y.
Yeah.
The theory with all the super partners.
That's the one.
Yeah.
So SUEY proposes that every known particle has a heavier, undiscovered partner particle.
Okay.
And if we find these superpartners, it could solve some of the biggest mysteries in physics, like why the Higgs boson is so much lighter than expected.
Okay, so why is the Higgs boson's mass such a big deal?
Well, according to our current understanding, the Higgs boson should be a lot heavier than it actually is.
Oh.
It's like expecting a bowling ball to weigh the same as a feather. It doesn't add up.
It doesn't make sense.
CERN could explain this discrepancy by introducing these superpartner particles
Right.
that interact with the Higgs boson and kind of keep its mass down.
So finding these super partners would be like finding the missing pieces that explain why the Higgs is the weight it is. And it would point to a more complete theory of the universe.
Yeah, potentially unifying the fundamental forces of nature like gravity and electromagnetism into one framework.
Wow. A unified theory of everything. I mean, that's like the holy grail for physicists, isn't it?
This is.
And the LHC could help us get there.
It's a possibility.
So we've got dark matter, we've got supersymmetry. What else? What other mysteries are LHC researchers hoping to unlock?
Well, there's the question of extra dimensions, for example.
Okay, wait. Extra dimensions, like a portal to another universe? Is that what you're talking about?
No, not exactly.
Okay.
But the idea is that there might be more dimensions than the three spatial dimensions and one time dimension that we experience.
Okay.
So these extra dimensions, they could be curled up at incredibly small scales.
Okay.
Too small for us to see directly. But if they exist, the LHC might be able to produce particles that interact with them.
I see. So we might not be stepping through portals to other worlds anytime soon, but the possibility of hidden dimensions is still pretty mind-blowing.
It is.
Okay. What other weird and wonderful things might the LHC reveal?
Well, there's the study of exotic particles.
Okay.
You know, we know about protons, neutrons, and electrons, but there's a whole zoo of other particles that are much more exotic.
Give me an example.
Well, there are these particles called tetraquarks and pentaquarks, which are made up of 4 and 5 quarks, unlike the usual 2 or 3 quarks in protons and neutrons.
Wow.
And then there are hypothetical particles like magnetic monopoles, particles with only one magnetic pole, unlike the north and south poles we see in normal magnets.
Okay, so the LHC is basically a particle zoo where we're discovering all these strange and wonderful creatures that challenge what we thought we knew about matter itself.
That's a great way to put it.
And each discovery gets us closer to a more complete picture of the universe and how it all works. This is incredible, but it also sounds expensive. Is it worth it? I mean, all this research.
It absolutely is. Aside from the profound scientific discoveries, the LHC has also led to amazing technological advancements.
Okay, so it's not just about understanding the universe, but about improving our lives here on Earth.
Exactly. The LHC is a perfect example of how fundamental research can have tangible benefits for society.
All right, so we've established that the LAC is this amazing machine doing incredible things. Let's get into the nuts and bolts of how it actually works. You mentioned these four main experiments, ATLS, CMS, ALICE, and LHCb. Can you give us a quick tour of each one?
Sure, yeah. So ATLS and CMS, they're the two general purpose detectors. They're massive, incredibly complex structures
Really?
with layers upon layers of detectors designed to track and identify different types of particles.
Right.
Think of them as giant 3D cameras that capture the debris from these proton collisions.
So ATLAs and CMS are like the workhorses of the LHC.
Yeah, you could say that.
Okay, okay. What about ALICE and LHCb? What do they do?
Well, Alice is specialized in studying heavy ion collisions.
Heavy ion collisions.
Yeah, so instead of colliding protons, they smash together lead nuclei, which are much heavier.
Okay.
And this creates an extremely hot, dense state of matter called quark-gluon plasma.
Quark-Gluon plasma.
Yeah, and it's thought to have existed, in the first few microseconds after the Big Bang.
So they're recreating the conditions of the early universe.
In a way, yes.
Wow, that's wild. And LHCb.
LHCb, it focuses on particles containing the beauty quark, also known as the bottom quark.
The beauty quark.
Yeah, and they're trying to understand why the universe is made up mostly of matter and not antimatter.
Right.
It's a big puzzle, and LHCb is looking for clues.
So four experiments, each with its own focus, all working together to unravel the secrets of the universe.
That's right.
It's a pretty amazing feat of engineering and collaboration.
It really is.
The LHC is really a testament to human ingenuity and our desire to understand the world around us.
It is.
I think we've covered a lot of ground in this first part of our deep dive into the Large Hadron Collider. Before we go on to part two, let's just let everything sink in. This machine, this global collaboration, this quest for knowledge, it's pretty awe-inspiring.
It really is.
The LHC is really a symbol of human potential and our pursuit of understanding. It reminds us that even the most complex questions about the universe can be tackled with ingenuity, with collaboration, and a lot of hard work.
I agree.
Now, take a deep breath, everyone, because in part two of our deep dive, we're going to explore those potential discoveries waiting to be made at the LHC, what groundbreaking findings might be just around the corner, and how will they change our view of the universe. Stick around, and we'll find out together.
Looking forward to it. Welcome back to our deep dive into the Large Hadron Collider. I'm ready to delve deeper into the mysteries of the universe, if you are.
Absolutely. In the last part, we talked about the amazing engineering and technology behind the LHC, those four incredible experiments, ATL, CMS, ALICE, and LHCb, and the quest to understand the fundamental building blocks of the universe. But now I want to look ahead. What's next for the LHC? What groundbreaking discoveries might be waiting just around the corner?
Well, one of the most exciting prospects is the potential for discovering dark matter particles.
Okay.
With the LHC's upcoming upgrades and the increased number of collisions, we might finally be able to produce and detect these elusive particles.
Okay, so we talked a bit about dark matter before. It makes up most of the matter in the universe, but we can't see it. Can you remind me why scientists think it exists in the first place if it's invisible?
It's all about gravity. Astronomers have observed that galaxies rotate faster than they should based on the visible matter we can see. There's simply not enough gravity from the stars and gas to hold them together. So they theorize that there must be some invisible matter, this dark matter, providing the extra gravity to keep everything from flying apart.
So it's like there's this hidden scaffolding holding the universe together.
Yeah.
And we're trying to figure out what it's made of.
Exactly. And the LHC could be the key to unlocking that mystery. If dark matter particles are produced in the collisions, they might interact with the detectors, leaving behind telltale signs that we can analyze.
That would be huge. Unmasking dark matter. It would completely change our understanding of the universe.
It would be a paradigm shift for sure. And that's not the only exciting prospect. The LHC is also searching for evidence of supersymmetry, or CCY for short.
Right. Sissy, why you mentioned this earlier, the theory with all the superpartners?
Yes, CCYY proposes that every known particle has a heavier, undiscovered partner particle. If we find evidence for these superpartners, it could solve some of the biggest mysteries in physics, including why the Higgs boson is so much lighter than expected.
Okay, help me out here. Why is the Higgs boson's mass such a big deal?
Well, according to our current understanding of particle physics, the Higgs boson should be much heavier than it is. It's like expecting a bowling ball to weigh as much as a feather. Something doesn't quite add up. CEY could explain this discrepancy by introducing these superpartner particles that interact with the Higgs boson in a way that keeps its mass down.
So finding these superpartners would be like finding the missing pieces of the puzzle that explain why the Higgs boson is the way it is.
Precisely. And it would also point towards a more complete and elegant theory of the universe, potentially unifying the fundamental forces of nature into a single framework.
A unified theory of everything. That's the holy grail of physics, isn't it?
It is. And the LHC might just be the tool that gets us there.
Okay, so we've got dark matter and supersymmetry, but I have a feeling there's more. What other mysteries are the LHC researchers hoping to unravel?
Well, there's the question of extra dimensions, for example. Some theories suggest that there might be more dimensions than the 3 spatial dimensions and 1 time dimension that we experience.
Okay, wait. Extra dimensions. Like a secret portal to another universe kind of thing.
It's not quite as simple as that, but the idea is that these extra dimensions could be curled up at incredibly small scales, too small for us to detect directly. But if they exist, the LHC might be able to produce particles that interact with these extra dimensions, giving us indirect evidence of their existence.
Okay, so we might not be stepping through portals anytime soon, but the possibility of hidden dimensions is still pretty mind-blowing.
Yeah.
What other strange and wonderful things might the LHC reveal?
There's also the study of exotic particles. We know about the fundamental particles that make up atoms, protons, neutrons, and electrons, but there's a whole zoo of other particles out there that we're only beginning to understand.
Exotic particles. Give me some examples.
Well, there are particles called tetraquarks and pentaquarks, which are made up of 4 and 5 quarks, respectively, unlike the usual 2 or 3 quarks found in protons and neutrons. And then there are hypothetical particles, like magnetic monopoles particles with only 1 magnetic pole, unlike the usual north and south poles we see in magnets.
Okay, so the LHC is like a particle zoo where we're discovering all these strange and wonderful creatures that challenge our understanding of matter itself.
That's a great way to put it. And each new discovery brings us closer to a more complete picture of the universe and the fundamental laws that govern it.
So we've got the search for dark matter, the hunt for superpartners, the possibility of extra dimensions, and a whole menagerie of exotic particles. It sounds like the LHC is like a giant physics playground where the most mind-bending ideas are put to the test.
It is, and with the upcoming upgrades like the high luminosity LHC, we're going to have even more data to analyze, which means even more potential for groundbreaking discoveries.
Right, the high luminosity LHC. You mentioned this before. What exactly is that?
It's a major upgrade to the LHC that will increase the number of collisions by a factor of 10. This means we'll be able to study rare events in much greater detail and potentially discover even more elusive particles.
So it's like giving the LHC a turbo boost, allowing it to explore the universe with even greater precision.
Exactly. And with this increased precision, we might even be able to see subtle deviations from the standard model of particle physics, hinting at new physics beyond our current understanding.
So it's not just about finding new particles, but also about refining our understanding of the existing ones and potentially discovering entirely new laws of physics.
That's the beauty of scientific exploration. We're constantly pushing the boundaries of what we know, and the LHC is at the forefront of that endeavor.
This is all so incredibly exciting. But I can't help but wonder, with all this talk of dark matter, supersymmetry, and extra dimensions, are we getting a little too carried away? Is it possible that some of these theories are just well too out there?
That's a valid question, and it's important to remember that science is a process of testing and refining our ideas. Not all theories pan out, but that's part of the beauty of it. We put our hypotheses to the test, and even if they're disproven, we learn something along the way.
So it's not just about finding answers, but also about asking the right questions and being open to the unexpected.
Exactly. And the LHC is an incredible tool for doing just that. It's allowing us to ask some of the most fundamental questions about the universe and to explore realms of physics that were once considered purely theoretical.
This is all so fascinating. But before we get lost in the excitement of potential discoveries, let's take a step back and talk about the practical implications of all this research. We touched on this briefly before, but I'd love to dive a little deeper. How is the LHC impacting our lives here on Earth?
Well, one of the most significant impacts is in the field of computing. The LHC generates an absolutely massive amount of data, and that has driven the development of new technologies for storing, processing, and analyzing this data.
Okay, so it's not just about the physics, but also about the technology needed to handle all the data.
Exactly. And those technologies have applications far beyond particle physics. Grid computing, for example, which allows researchers around the world to share computing resources and collaborate more effectively, was initially developed to handle the LHC data.
So the LHC is basically a giant data factory, and the need to handle all that data is driving innovation in computing.
Precisely. And these advancements have applications in fields like medicine, finance, climate modeling, and countless others.
That's incredible. It's amazing to think that this quest to understand the universe at the smallest scale is also having a real-world impact on our lives.
Absolutely. And it doesn't stop there. The LHC has also led to breakthroughs in medical imaging. For example, the technology used in PET scans, which allowed doctors to see inside the human body, was originally developed for particle physics detectors.
So the same technology that's helping us explore the mysteries of the universe is also helping us diagnose and treat diseases.
That's right. And then there's proton therapy, a type of cancer treatment that uses beams of protons to target tumors with incredible precision, minimizing damage to surrounding healthy tissue. This technology also has its roots in the development of particle accelerators like the LHC.
Wow, I had no idea the LHC had such a wide-reaching impact. It's really inspiring to see how fundamental research can lead to practical benefits for humanity.
And let's not forget the international collaboration aspect of the LHC. It's a truly global project, with scientists from over 100 countries working together, sharing their expertise, and pushing the boundaries of knowledge.
It's a reminder that science can be a powerful force for unity and cooperation. In a world that sometimes feels increasingly divided, it's heartwarming to see people from all walks of life coming together to unravel the mysteries of the universe.
I couldn't agree more. The LHC is a testament to the power of human collaboration and our shared thirst for knowledge. It's a symbol of what we can achieve when we work together towards a common goal.
All right, we've talked about the incredible potential for discovery at the LHC, the technological spin-offs that are already benefiting society, and the inspiring global collaboration that makes it all possible. But I have one more question before we wrap up this part of our deep dive. With all this talk of pushing the boundaries of knowledge,
Hmm.
is there a limit to what we can learn from the LHC? Is there a point where we hit a wall, so to speak?
That's a great question, and it's one that physicists are constantly grappling with. The LHC is an incredibly powerful tool, but it does have limitations. Eventually, we'll need even more powerful machines to probe deeper into the mysteries of the universe.
So what's next? What's on the horizon for particle physics after the LHC?
Well, CERN is already exploring the possibility of building a future circular collider, or FCC for short.
Oh, on a future circular collider, how big are we talking
We're
here?
talking big. The FCC would have a circumference of almost 100 kilometers, dwarfing the LHC.
100 kilometers. That's like circling a small city. What would they hope to achieve with a machine that big?
The FCC would be capable of reaching energies 10 times higher than the LHC, opening up a whole new realm of particle physics to explore. It could potentially answer questions about the nature of dark matter, the origins of the universe, and the very fabric of space and time that are simply beyond the reach of our current technology.
Okay, that is officially mind-blowing. It seems like every time we answer one question about the universe, 10 more pop up in its place.
That's the beauty of science. It's a never-ending journey of discovery, and the LHC and perhaps the FCC in the future are powerful engines driving that journey forward.
I'm ready for part 3. How about you?
Hmm.
Welcome back to our final part of this deep dive into the Large Hadron Collider. It's been amazing, and I feel like my brain's about to burst with all this incredible stuff about this mega machine and the mysteries it's trying to solve. But before we say goodbye to the world of particle physics, I've got a few more questions I just got to ask.
Yeah, let's hear them.
Okay, so in the last part, we touched on that future circular collider, the FCC, this gigantic 100-kilometer machine They could, like, take particle physics to a whole new level. But that's way, way down the line, right? What about right now? What's next for the LHC in the coming years?
Well, even without a new collider for quite a while, the data we've got from the LHC will keep physicists busy for years and years. There might be secrets hiding in there, just waiting for the right analysis techniques, to unlock them.
That's true. It's like having a treasure chest that just keeps giving.
Hmm.
Speaking of the future, though, are there other ways to do particle physics without these massive colliders? I mean, I get they're incredible, but they're also super expensive and complicated.
You're not wrong there. Colliders are incredibly complex and they don't come cheap, but they are powerful tools for getting to the bottom of what matter is all about. There are other ways, though, yeah. For instance, some physicists are trying to find dark matter particles using detectors that are buried deep underground.
So instead of creating them by smashing things together, they're trying to catch the dark matter particles that are already out there just passing through.
Exactly. The thinking is, if dark matter is real, it's got to be passing through Earth all the time. These detectors, deep underground, they're shielded from cosmic rays and they're super sensitive, designed to pick up even the tiniest signals that could be a dark matter particle interacting with the detector material.
So it's not all about brute force. There are subtler ways to get at the universe's secrets.
Right. Particle physics, it's a big field with lots of different approaches. Researchers are using all sorts of techniques to understand the universe. Some experiments that even happen on tabletops, using lasers and other fancy equipment to study particle behavior.
So not everything needs to be gigantic and expensive. There's room for the smaller, more focused stuff, too.
For sure. Each approach has its own pluses and minuses, and when we combine the results from different kinds of experiments, we get a fuller picture of the universe.
It just goes to show that science isn't about just one right way to do things. It's about exploring every path, asking questions, being open to new ideas and new ways of doing things.
Yeah, couldn't agree more. That variety of approaches is what keeps science so alive, so interesting.
All right, we've talked the science, the tech, the global teamwork, what might be found in the future, even other ways to look at particle physics. But there's one last thing I want to get to before we wrap up, and that's what all this means philosophically. I mean, the LHC's discoveries, what do they tell us about ourselves?
Ah, good point. The LHC isn't just about data and theories, it's also about those big questions, the nature of reality, our place in the universe, the whole meaning of existence even.
Okay, you've got me hooked. Tell me more. How does the LHC connect to these like really deep questions?
Take the Higgs boson. Discovering it, that confirmed there's a field right through all of space that gives particles mass. That's a pretty heavy concept, and it affects how we understand everything from the very beginning of the universe to how matter is structured at the most basic level.
It's like we found this invisible hand shaping the universe, this fundamental force we had no clue about until just recently.
Yeah, exactly.
Yeah.
And then there's the hunt for dark matter and supersymmetry. If we find evidence for them, it could totally change our picture of the cosmos. It might even suggest that our universe is just one among many, like part of a huge multiverse.
Okay, my head's spinning a bit now. Multiverses, hidden dimensions, dark matter, it's all starting to sound like a science fiction story.
Well, like we've been saying, sometimes truth is stranger than fiction. The LHC, it's pushing the limits of what we know. With each discovery, we got to rethink our place in the grand scheme of things.
It's humbling, and at the same time, it's super exciting. Makes you realize how much we still don't know about the universe and how much is out there to discover.
And that's what makes it so captivating. The search for knowledge, it never ends. And the LHC, it's this powerful tool that helps us on that journey.
Well, I think this brings us to the end of our deep dive into the Large Hadron Collider. It's been an amazing journey, and I've learned so much. Honestly, I went from feeling intimidated by particle physics to being totally blown away by how awesome and complex it is.
It's been great sharing this exploration with you. I love seeing people getting excited about the amazing world of particle physics.
Before we go, any last words of wisdom for our listeners?
Just this. Never stop questioning. Be curious about the world, about the universe. Never lose that sense of wonder. There are so many mysteries out there, and it's up to us to uncover them.
Perfectly put. And to all our listeners, thanks for joining us on this incredible journey through particle physics. We hope you had a great time. Don't forget to subscribe to the Deep Dive for more fascinating explorations of everything that makes the universe tick.
Until next time, keep exploring.